Okay, so some more LeetCode. Yeah, alright. First, type. Let's do 50. Oh shit, okay. Oh my god. Alright. Accuracy is bad. Yeah, alright. Alright, so where did we leave off? We left off, I think, was... Let's check my GitHub. Alright. LeetCode 175 2-pointer. I think it was container with most water. So I already did these ones before, but it's been quite some time. So I think container, so we're starting sliding window. So we are starting sliding window. Is that right? Yeah, okay. Sliding window. And we can do less time sell stocks and notes.md and CBP. And yeah. Okay. Alright. So what I can do is to put that in here. Okay. Alright, please don't show me the answer. Please don't show me. Actually, I think it's time to buy and sell stock. Just go here. Hopefully it's blank. Okay, perfect. It is blank. I'm just gonna grab function definition, put that there. Vector. Oh god. Alright. So that should be set. Okay. Notes. Had I stopped my notes before? Okay, very simple. Alright, what do we know about the problem? You're given an array, prices, where prices I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can receive from this transaction. If you cannot achieve any profit, return 0. So we're basically saying we can't return a negative profit. So if we don't have any positive profit, we just have to return 0. Okay, let's write this down. Find profit to buy and sell stock given input array. Right. Can't return a negative. 4 is at 0. What else? Yeah, that's it. Price's length is always guaranteed to be 1. Price's I. That's interesting. So if it's 1, what does that mean? Can you buy and sell within the same day? I'm assuming. Yeah. Okay. So let's take this to the whiteboard, right? So 76431. Actually, let's do a different one. 715364. Alright, so oh god, it's too big. 715 364 364. So from my understanding is that we're trying to find the maximum profit, right? Each one of these elements represent a profit, right? So array at index I represents monetary profit amount, right? We are trying to maximize our profit by choosing two indices, right? Let's just call them x and y. X and y, right? Where x is buying price or purchase price, right? Purchase price, and y is selling price. Okay. What we want to do is try and find the maximum profit, right? So my first initial idea is, okay, let's say we had a pointer here, right? Let's say left pointer, and then let's just say right pointer starts the one adjacent to the left, right? Because even if it starts here, right, we can't, if we buy and sell within the same day, we're just returning 0, so that doesn't really tell us anything, right? So let's start here. To find the profit, it's just array of r minus array of l, and that gets us the profit, right? And so this profit is negative. I believe that tells us that we should move the right pointer to the right, right? And the reason we do that is because there could be something where the answer includes the 7, right? Is that the case though? So if we know that, let's say given two numbers, right, 7 and 1, if we know that the profit is negative here, do we want to keep the left pointer here or move it to the right, right? And I believe the answer is actually move it to the right, because let's say we had a number, let's say 100, right? Some really large number. Or actually, let's change it to 2, right? If we kept it there, then our right pointer would go here, right? And we're still saying it's negative, right? So it's going to continue on down this loop. But let's say our array was actually just this right here, then we would have missed this maximum profit interval, where the max profit would be 1, right? So if it's negative, I believe it's actually better to move the left pointer to the right, because we're trying to maximize our profit. And for instance, if we had 7, 1, and let's say a number larger than 7 is 100, right? We could argue that this is a potential max profit, right? 100 minus 7 could be a potential max profit. But again, because r was here initially and this gave us a negative, that prompts us to move left, or the L pointer to the left, because we know we're going to get a larger profit that doesn't start with this, just because we know that this number was smaller. So a lot of words I said, but the idea is that we want the left pointer, oh god, put my pencil back. So we want the left pointer to be pointing to the lowest possible amount in order to maximize our profit, I believe. So here's what the pseudocode will look like, right? So pseudo, how did I do this? Let's just say CPP. Alright, so some pseudocode is that we want to initialize left and right pointer, right, L is equal to 0, R is equal to 1, right, and while R is not at the end, right, we just want to say something like, we want to move our pointer every iteration, I believe. Is that when we would want to move? Okay, so we know when to move the left pointer. What about the R pointer? I believe it's if the profit is positive, right? Because now if the profit is positive, let's say we had this case right here, left, right. The profit is positive in this case, so we move the right pointer here. It's negative in this case, so we move the left pointer here, and again it's negative, so we move it here, and then we move it here. So I guess, because if the profit is positive, we technically, if L is going to be pointing to the lowest possible number within our profit interval or range, then R should do the opposite and point to the highest number possible in our max interval range to get us the max profit. So that does make sense. So move R pointer, so calculate profit. Profit is equal to just array at r minus array at l, right? And if profit is greater than 0, then we would want to do plus plus r, right? Else we would want to do plus plus l. And pretty sure that's it, right? If it's actually greater than or equal to 0, we would do that, and then we would keep track of max profit, right? So max profit, keep track of that and update it. So I'm pretty sure that's what the code should be. Hopefully. Let's do const expression. No, I can't do const expression because this isn't decided at compile time. So const is size t, I is equal to prices at size, right? And L is equal to 0, and R is equal to 1, right? And actually, if prices, I don't know why I named I. If the size is already 1, then we know that the max profit is just 0, right? You can just buy and sell it in the same day. And we can have a max profit is equal to how to use in C++. What's the library I need? C limits. C limits. And then we want to calculate profit, right? So we want to say something like incur profit is equal to array at r minus array at l, not array but prices. And if incur profit is greater than, and we want to update max profit first actually. So std max incur profit max profit. If incur profit is greater than or equal to 0, right, then we want to move the r pointer. Else we want to move the l pointer. And then we want to return max profit. Oh god. Max profit. Okay. Yeah, this should be it, hopefully. We're gonna see. Let's do a couple trace threes, right? So 715364. So 715364, and we're gonna say MP is gonna be equal to nothing or 0, right? So actually, yeah, max profit will always be 0. If we want to get fancy, we could say unit 32. Okay. Yeah, I don't need this time. So 715364, right? Let's say L starts here, R starts here, right? Max profit is negative, so we're gonna move the R over here. Again, oh shit, wait. I meant we're gonna move L here. And actually, when it's negative, we always want R to be ahead of L, right? Because it doesn't make sense to sell before you buy it. So I guess that means we're just going to increment both, actually. So back in here, right, we would say something like plus plus L plus plus R. Or we could just say something like this, right? Remove that. So R goes here, right? And then now max profit turns into 4. Max profit still 4. Max profit turns into 5. And so on. Yep, okay, that makes sense. That makes sense. So we essentially want L to be at the largest. Okay, smallest and R at the largest. So this should actually be the right code, I believe. hopefully this should, I need to log in. Should probably pause it. Alright. Oh shit, wait. Don't look at it, don't look at it, don't look at it. Okay. Okay. Can I run it? Okay, wrong answer. What I got was 0, actually, and expected was 5. Okay. Interesting. Prices that size. It's not this because this looks fine. R is greater than N. Current profit is prices R minus L, right? It actually should be less than 0. Oh my gosh. Okay. Less than 0, right? We increase R and we increase L. Let's run this again. Current profit. Interesting. Well, prices.length can't be 0, so, or actually it could, but we catch that, no? We catch it here, right? Runtime error. Okay. I'm trying to think what could cause it. What was the input? 715364, right? So N is going to be 6, right? So L is equal to 0, R is equal to 1. We say max profit prices R minus prices at L, right? Gets to there. It's negative, so we increment both, right? I think it's okay. If it's negative, I'm tripping, bro. If it's negative, we want to increase R and increase L, right? If it's positive, we just want to increase R. So actually, it should be something like this. Hopefully, it should be something like that. Okay, nice. Let's submit. Whoa, there's no UI. Okay, output was 1. What's the max profit here? Max profit could be is 2. So L starts here, R starts here, right? If I take this actually and do that, L here, R here, right? Because it's negative, then we're gonna increment both and say R belongs there, L belongs here, and then boom, right? Since this is positive, we're gonna move this here. Since this is still positive, or at least not less than 0, we're gonna move this here, and then this is negative now, right? I see. Okay, so again, we want the left pointer to basically point to the minimum most amount, and then, right, because the max profit will always include L pointing at the minimum most amount, right? So if we do that, then actually, if the profit is not negative, then we actually just want to assign L to where R is at. So L is equal to R. Because R found the newest minimum, so that's where L should be pointing at, right? Make sure it submits there. Nice. Okay. Now let's say go to one. So, and prices, int max, profit, mini is equal to min, many price is I, right? Profit is equal to, okay, you know what this looks like? This looks like dynamic programming. Is it really a sliding window? Topics, it's dynamic programming too. Okay, so I guess let's look at the dynamic programming way. It kind of did sound like dynamic programming too, just because you could build a solution bottom up. So what does that look like, right? So many is equal to, you're just trying to find the minimum. Okay, find the minimum of their prices. Profit, again, is just profit, which starts at 0 between prices I and many. Okay, yeah. So that makes sense, because the profit is always the minimum of the day, so you can build it up like that. So essentially what they're saying is that, so say we had 7, 1, 5, 3, 6, 4, right? We're trying to find the minimum. Where's the minimum at? Is, let's say, where did they start at? I is equal to 0. So building up the dynamic programming solution, you do something like this, right? Where the max profit in this day is, let's just say it could be, so the minimum, or at I, again, if so we're saying that we're comparing it to in max, the minimum between this, the minimum and 7 is going to be 7, but the profit is going to be 0, right? Profit 0, or it'd be 7 minus 7, which is 0, so you can have a profit of 0 at this day, right? Now at 1, the minimum would be, what would the minimum be? Price is I, right? And again, the new minimum is 7, right? So the new minimum is actually now 1, right? And then again, the profit was going to be 0, right? So now the profit could be 1 at this day? Is that what he's saying? Price is I minus many. Yeah. 1 minus the minimum. The minimum being 1, which would just actually be 0 as well. Okay. So now here we're at 5, right? The minimum doesn't get updated, but now the profit is just 5 minus the minimum, which is 4. Oh, I see. Okay. Very cool. So the minimum stays here as we traverse, right? Now let's say 0 was here. Now we have a new minimum. This gets updated as new minimum, right? But every day before the 0, which is represented in, let's say, the ith index of our DP array, it's just, we know that basically everything we calculate in our dynamic programming rate up to here is correct to find the maximum profit for this interval, right? But now since we found a new minimum, there could be a potential max profit in this interval. So it could be dynamic programming in that sense, I believe. Alright, nice. I'm going to say that was a success. Complete max profit. Okay, and let's do, just copy this, let's paste that there, right here. Interesting. It's not for that one. It's not for that one. It's for this one. Okay, submit. Nice. Okay, what's the next one? What are we at? We spent around 25 minutes on that one. Okay, it's pretty bad. Can't lie. Next one would be longest substring. Please don't show the answer. Okay, longest substring without repeating characters. We can just read it here. Yeah, just right here. Longest substring Okay. Let me grab the template. Okay, great. Reset. My Vim motions are whack. Okay, that's whatever. We can say return, and then we can say length of longest substring without repeats. Let's just do size t as equal to s dot size length. Okay, so given a string, find the length of the longest substring without duplicate characters. A substring is a continuous sequence of characters within a string, right? So, okay, what my mind automatically goes to is, what's an example one we had? It was zxy, zxyz. So zxy, zxyz. Right, so eyeballing it, right, the longest substring is 3, right? It could be either this, it could be this, it could be this, it could be this, it could be a whole bunch of ones, right? So longest substring was 3. How do we find that? What I'm thinking is a sliding window again, right? So L here, again R here. We don't want R starting at the first index because that would mean that it's a repeating character, right? So let's just start here. If they're not repeating, right, then we would move R to the right? Not repeating. We're keeping track of the max length, by the way. So now it's 3. Nice. Here, we have a repeating character, right? So in this instance, do we want to bring L to where R is at, like last problem, or just move it up incrementally? And I think moving it up incrementally is the answer. So moving it incrementally, right, and then we want to move R, possibly. Or actually, what we want to do, right, is because, let's say that, what if this was the case? So L is here, right, R is here. There's no repeating characters, so we can move R here. There is a repeating character, so we move L here. There's still a repeating character, so we move L here. Okay, so when there's a repeating character, let me write this down. When there is if repeating character, okay, so it is a sliding window solution, I believe, where L is equal to 0, R is equal to 1, right? What we want to answer is when to move L, right? And where to move it, right? If repeating character is substring, let me write pseudocode for this. So if repeating character in substring, then we want to move L until, and this is an important part, until no repeating character in substring, right? Because like this instance, right, we can't just move it once and assume that that'll fix it, right? We have to move it until it's valid. Yeah, so another question we have to answer is when to move R, right? When to move R is when we want to move R? When there's no repeating character, right? If no repeating character, then just move R one space. Nice. And then another thing we want to solve is how to answer the question of repeating characters. Well, we can use a frequency map, set maybe, STD array if we want to be memory efficient, right? Because does the problem say printable ASCII characters? So maybe not STD array, because if it was just lowercase alphabets, then STD array of size, let's say 26, would be valid, but it's not, because it's any printable ASCII character. So I think set could work here, a set of chars, an ordered set. Yeah, I think that's the solution. So let's try coding this up and trace a couple of problems out. Here we want an unordered set. STD unordered set. It'd be a char, right? And then we just say S or S set. Okay. Again, the idea was to initialize a left and right pointer. So L is there, R is 1, right? And then we can say something like while R is less than N, of course, and then we want to keep track of the max substring, right? So, and max substring, max length would be 0 initially, right? Okay, so we want to do is SL length could be 0, right, or 1. So we could say something. We can have a base case here to say if n is less than or equal to 1, right, then just return s dot length. Okay. Now if it's 2, then we can automatically append to our set, right? We can say init set with curved pointers, right? So we can say sset dot insert, right? We can say s at o, and then we can say s at r. Okay, and this will be our loop, right? I think actually just s dot r, right? Actually, no, it'll be s at o. So if our set is this, right, then we, in our L and R starting here initially, we want to populate it with just L, so that at the beginning of the loop we can populate it with R and see if the set already contains that matching character, right? So we can say something like auto IT equal, do I need that? Right. Is equal to s dot set dot insert SR. Did I do this right? Iterator bool. I'm pretty sure a set dot insert returns a pair, an iterator and a boolean. Yeah. So why can't I do a structured binding? std iterate, std pair iterator bool. Const auto No, this is still not valid. How come? Let's ask chat. How come this tags structure is Oh shit, I'm stupid. Okay. Inserted. Right. Okay. If not inserted, this means that there is a repeated character. Right, so that means, if we're referencing our notes, if repeating character, move L until no repeating character. Right. So while while it hasn't been inserted, right? Plus L, right? Okay, how do we want to do this? How do we want to structure our code? Maybe we can just find it. Maybe we're being too fancy with structured binding. So, bool exists, right? Or maybe repeat. Repeat is... but that made sense. Because we're also inserting R. So, let me just do this. So, repeat. Okay. Well, if it's not inserted, that means it's a repeated char, right? We can't also modify. Okay, we can. So we want a plus L, right? Until there is no repeated character. So we can just check inserted is equal. I don't like the term inserted. I would say maybe repeat, right? So but okay, for purposes, I'm gonna say repeat is equal to it's not inserted, right? If it's not inserted, then there's a repeated character, right? So if there's a repeat, right? While there's a repeated character, increment L, and then set find I'm not trying to do a find. What is this return? Returns an iterator. Okay, that's fine. I said define SR, right? So let's just do this. Auto IT is equal to set.find SR, right? Is a set the right way to go about this? Because also, so say LR is here, right? Our set is initially populated with Z, right? And then we're gonna populate with X, then we're gonna move R's here, we're gonna populate with Y, right? Let's do this part first. Else we can just populate it, right? With, or we just move R. Then we calculate the max length, right? So max length is equal to std max. See widths. Here we want to say then max between max length and r minus l. Okay. Now while repeat, if there's a repeat, just increment L until it's valid. Now auto it is equal to sset.find, and if let's continue tracing this part out, right? So now we land at z. We try inserting z, that's false, right? So we have to increment L and actually remove the z. It's a set.remove C++. Ordered set. Erase member function. Return value. Okay, so that sounds good. So we're gonna increase the L, but before we do, we actually want to remove it from the set. So sset.remove or erase. Erase. Let's just say it takes an iterator though. Is that true? Oh, okay. No, we can do it by value. Okay. Let's do set L, right? Then plus L, and then try and find the element we tried inserting again. Or maybe we could say oh god, this looks bad. IT2, right? If it's been inserted. Actually, okay, let's think, right? I don't think I need this else statement, and I don't think I need this repeat statement. Okay. So actually, we're just gonna say while there is a repeat, right? What we want to do is again sset.erase set L plus the L, right? Or we can even do, let me see here, plus there. And then we could say something like, actually to make it more readable, this is fine. Then we could say something like auto it inserted. Actually, can I do something like this? Is equal to sset.insert sat r. This is valid. Expected body of a lambda function. This is valid in C++ where I'm trying to reuse the variables of a structure created by structured binding to use again in another structured binding statement. Assign it to a pair first. Use std tie. No, we're gonna stick with modern C++. Okay, so that's not valid, right? Maybe I'm just overdoing it again, right? So let's just say if sset.find r is not equal or does not equal to s.n, right? Or actually, we're gonna say is equal to s.n, and we're gonna say repeat false. Repeats it false. Okay, so increase O if R is no longer in the set. repeat to false, right? Okay, actually, auto result, we're gonna use chat's way, so s dot insert r, right? And then if IT2 curious, will this result in a double declaration of the same variables? Okay, we're just gonna say this, right? So, and I guess it's gonna be a constant. So, if inserted, if it was inserted, that means there's no more repeats, right? So repeat is equal to false. Yeah, and that's pretty much it. While repeat I think that's it. Okay, let's say we had XYZ, XYZ, X, right? So in order to set, right, our set would be, it contained X initially, right? And then we're here, max length, right? So max length is gonna be equal to, like, let's just say 0, right? Here we can actually just assign this to 0. Okay. Okay, that's fine. So here we're saying try and insert S at R, right? And R would currently be here, right? So try and insert S at R. Alright, yeah, that would work, right? So, we would insert S at R, which would be Y, right? And then we would increase R. So increase R, right? And mind you, L is right there. Okay. We would actually increase R to here, and that would mean that max length, before we increased R, max length was actually going to be 1. So 1, right? Then we increase R to here. Again, was it inserted? Yes, it was, right? Then we're going to find the max length. Max length would be probably just 2, right? 2. And then actually it'd be max length plus 1. Then we're going to try here, right? And no, this won't be inserted because the set already contains an X, right? So we're actually going to erase that X and increase L, right? Increase L, then we're here, right? And try and insert it again. Can we insert it? This time we can, right? So if it was inserted, set repeat to false. That should be it. Okay. Maybe I don't need the plus 1. No, that's actually not the answer. Why? Okay, let's debug with this, right? Let's bring this in here. Right, we could do it here. So the way it works is that L is here, R is here, right? Our set currently contains A and B, right? Or just A, actually. We're gonna try and insert B, it works, right? So then we're here and we're trying to find, okay. So max length would just be 1 minus 0, so max length, right, ML is going to be 1. Okay, perfect. Now we're going to increase R to there, right? If we increase R to there, then the max length, it should be inserted, right, into here, and max length would be actually 2, right? And we're going to try here, and it doesn't work, so L, S out erase, S at L, and then plus plus L. So BCA, right, now we're able to insert A again, right, because we removed A, and then we inserted it back, right, and then max length, we find the max length, then we insert it again. So max length here would be 0, 1, 2, 3, 3 minus 1 is 2, but how am I getting 4? Oh, actually no. Okay, so then we move R here, right? This doesn't work because B is there, but then we move L there, right? And so now it works. Move C here, doesn't work, so we move L here, right? So now that works. Oh, but every time. CAB. Okay. So X, Y, ZXY, ZXY. So if we have ZXY, ZXY, Z, and L starts here, right? And our set starts with just Z, and R starts here. This is valid, we insert X, we move R. This is valid, we insert Y, we move R. This is not valid anymore, so we move L and remove Z. Right? Actually, no, this should work. Let's see. Okay, let's put in some debug outputs, right? So, let's see when it's repeating, right? So, CDC out L would be set L, right? And then let's just do that. Repeating, and then here valid, so that means it's not repeating. And then CDC out L is going to be set L. CDC out R is going to be SR. Let's run this. Okay. So let's valid AB, right? Valid AC, right? Now L is A. So when there's a repeat, right? So it was valid up until AC, right? So L is A and it's not valid. So then L is now B, so BA is valid. And then we move here, so B is not valid, but CB is valid. CB is valid. Then remove R here, so L, last place L was at was C. And then ABC should be valid, so AC is valid. So AC is valid. Then B is here. How come AB is valid? Okay. So ABC, ABB. ABC, ABC, BB. So this set currently contains A, L is here, R is here, right? We insert R, nice. We move R here, we insert C, nice. We move R here, then it's not valid, so we remove A, we move L here, now it's valid, right? We insert back A, and then we move R here, right? So now it's not valid, we remove B, we insert B again, right? And now it moves here, now it moves here. This isn't valid, right? So we remove C, right? And then R goes there, R goes here. Oh. Wait, but there should be a B right there. So this shouldn't be valid. But it's saying AB is valid. Okay, interesting. Let's see. Let's see why. Okay, trace our code slowly. So say we had this, right? Say we had this. So we had that, right? L is here, R is here. Our set contains A. Max length is equal to, let's just say 0, right? So now max length is, we're going to try and insert R, right? So we're going to insert R, that was successful. We don't even insert here. Then max length is equal to 1. Nice, then we're going to increment R. Okay. We're going to try and insert C. It works. We don't even enter here. Max length would change from 2 minus 0 is 2. Okay, nice. So now R is here. We're going to try and insert it. It doesn't work, right? So this returns true. We insert here. We enter here. We erase S at L from the set. So erase S at L from the set. Plus L. Plus L, and then try inserting R again. Can we insert R? Yes, we can. So if it's inserted, repeat is false, so this doesn't iterate again. So we're out here. Max length, this is 0, 1, 2, 3. 3 minus 1 is 2. Okay, and then plus R. Okay, now we try to insert R. We can't insert R because a B exists there, so we're going to say B is. So we can't enter it, right? Then we're going to erase L, which is what I did right there, plus L, plus L, right? And then try inserting R. so we can, right? So if it's insert repeat is equal to false, the max length is still 2 plus plus r, right? Now we can't insert c. Okay. Now we can't insert c, so we erase s at l, right? And then plus plus it. So erase s at l and plus plus it. And then we try and insert art again. We can. Okay, nice. So that's valid, right? So here, valid AC. That's the part wrong. Okay, find the max length. Still 2, then plus plus r. Nice. Now we try and insert B. Now B should be invalid, right? Because we can't insert it in there. Exists a B already in our list, right? So how come it's saying that we just skip this part? It's saying we were able to actually insert B. Did I trace it wrong? Let's see. This is nice. Let's trace out. What the heck? Okay. Well, I guess that was the case. Alright, words. This should have just been SR. Complete. I'm so sure that repeats. Okay, should be it. Remove it, let me run it again. 15 milliseconds. They use a map or frequency map. If map.find is how hard is not equal to map.n, so it equals it, then else, whoa. If else less than or equal to map of s at r. Interesting. Okay. Well, that was it for me. Runtime should be end here, and we're never iterating through a character more than once, so it should remain open.